For the last problem, we will try to incorporate the lessons we learned from the previous quarter about kinematics of motion. So for example, a 7.747 jetliner lands and begins to slow down to a stop as it moves along the runway. If its mass is 3.5 times 10 raised to 5 kilograms, its speed is 27 meters per second, and the net braking force is 4.3 times 10 raised to 5 newtons. What is its speed 7.5 seconds later, and how far has it traveled in this time? So the way to answer this question is by writing the given first. So from the problem, you can see that we know the mass of the object, 3.5 times 10 raised to 5 kilograms. The speed initial, because the object is already in motion and will stop eventually. So V naught is 27 meters per second. And then the braking force it will experience is 4.3 times 10 raised to 5 newtons. The required in A is the speed of the object after 7.5 seconds. And then in letter B, it is looking for the displacement of the object after the same time, 7.5 seconds. So for the equation, for the velocity, we can actually identify this using the kinematic equations. But the problem is, we don't know a very important variable. That is the acceleration of the object. However, there's one way of solving this problem. You can pause the video if you want to try it yourself first. Okay, so one strategy here is using the second law of motion. So the second law states that the summation of forces is equal to the product of mass and acceleration. So from this problem or formula, we can conclude that the acceleration is the net force divided by the mass. And in the given, we have both values. So we just simply substitute the values. So the acceleration of the object is dependent on how much force has been applied or braking force has been applied on it. That is 4.3 times 10 raised to 5 newtons, and as well as how heavy the object is, 3.5 times 10 raised to 5 kilograms. Now, calculating the value, we get 1.23 meters per second squared. This is the acceleration of the plane. So from the moment the plane landed on the runway to say 7.5 seconds, the object will experience an acceleration of a constant acceleration of 1.23 meters per second squared. Now, in letter A, it is asking for the speed of the object after 7.5 seconds. So we use the kinematic equation we learned in the first quarter, the kinematic equation 1, where it is equal to V final is simply the V initial plus the product of acceleration and time. Substitute the values, and V naught is given in the problem, 27 meters per second, plus calculated 1.23 meters per second times the time, 7.5 seconds. The answer is, take note that the acceleration is negative because the plane will be braking. So it's moving from a high speed to a decreasing speed. Therefore, the acceleration of the object opposes its motion, and that acceleration is a negative acceleration. So substituting the values, we get 17.76 meters per second. So kindly look at the value. Notice that from a speed of 27 meters per second, after 7.5 seconds, the plane is now only moving at a speed of 17.76 meters per second. And lastly, for letter B, it's asking for how far has it traveled at this time. So we take the value of t to be 7.5 seconds still, and we just simply choose a kinematic equation. So in the kinematic equation 3, we had the formula displacement is equal to v initial times time plus 1/2 at squared. Substituting the values, 27 meters per second times the time of 7.5 seconds plus 1/2 times negative 1.23 meters per second squared times the time of 7.5 seconds will get squared, will get an answer equal to roughly around 168 meters. So meaning to say, the plane will be able to travel a distance of 168 meters in 7.5 seconds if the acceleration is constant with a value of negative 1.23 meters per second squared. So kindly notice that our solutions or problems still require some of our kinematic equations that we learned from the first quarter. That is all for this lecture video. Thank you.